Hey everyone, welcome back. Today we're going to be doing a deep dive into growing object-oriented software guided by tests
Oh, yeah.
by Steve Freeman and Nat Price.
Great book.
Yeah, and this book, it's kind of considered like a Bible
Hmm.
for test-driven development, and I'm really excited to kind of get into it and see how these
Yeah.
TDD experts, kind of guide us towards creating software that is both flexible and maintainable.
It's a classic for a reason, and what I find most interesting about this book is that they really emphasize that TDD is
Yeah.
not just about, catching bugs.
Right.
It's really a design practice
Yeah.
that profoundly shapes the way that you think about building software.
Okay, so let's unpack that a little bit. I mean, I think we all know that TDD means writing tests
Mm-hmm.
for the code, but I'm really interested in how this,
Right.
seemingly backward process actually leads to better design.
So imagine you're about to build a new feature, right?
Okay.
With TDD, you start by writing a test that describes exactly.
How you want that feature to behave.
Mm-hmm.
So this forces you to really think about the desired outcome
Okay.
before you dive into all the implementation details.
So is it like having a blueprint before you start building a house?
Exactly.
Okay.
Yeah, you're defining the structure and the functionality up front.
Okay, cool. And then here's where it gets really powerful,
Yeah.
I think, because by writing the test first, you're also creating this clear and unambiguous specification for the code you're about to write. And this acts as a guide,
Yeah,
helping you stay focused on delivering that intended functionality.
exactly. It's like you have a target to aim at. It
Right?
keeps you from getting lost in the weeds.
Okay. I like that metaphor a lot. But the book isn't just about TDD, in a vacuum, right? They tie it closely to object-oriented design principles.
Yeah, absolutely. They weave TDD and object-oriented design together seamlessly.
Okay.
They show how principles like separation of concerns, higher levels of abstraction,
Right.
context independence, and tell, don't ask can all be effectively implemented using this test-driven approach.
Okay. Can you remind me what that tell, don't ask principle is all about?
Sure, yeah. Tell, don't ask is all about designing objects that collaborate by sending messages
Okay.
rather than constantly querying each other for information.
Mm-hmm.
So for example, let's say you have an order object that needs to be shipped.
Okay.
Instead of the order object asking the shipping service object,
Right.
hey, are you ready to ship? It just tells the shipping service, ship this order.
Oh, okay. So it's more like delegating a task than requesting information.
Exactly.
Yeah. Okay. I can see how that would lead to like a more loosely coupled system
Mm-hmm.
where objects are less dependent on each other's, internal workings.
Yeah, you got it. And the authors really drive home this point
Yeah.
that TDD can help you discover and refine these patterns of communication between objects.
So you're saying that by writing tests first, we're essentially forced to think about how our objects will interact with each other, which in turn leads to better design.
That's the beauty of it. The tests act as a feedback mechanism,
Yeah,
guiding you towards a design that is both testable and adaptable.
I like that. And a key element to make all of this work are mock objects.
Right.
Ah, yes, mock objects, those clever stand-ins for real objects that we use in our tests.
Mm-hmm.
I remember being a bit intimidated by those when I first encountered them.
They can seem a bit mysterious at first, but they are incredibly valuable.
Okay.
Mock objects allow you to isolate the code you're testing
Okay.
by replacing external dependencies with controlled simulations.
Right.
This makes your tests more focused and less brittle.
Okay, I follow you, but I also remember reading about a specific principle that they're quite passionate about when
Yeah.
it comes to mocking, which is only mock types you own.
Right.
What's that all about?
It's a golden rule for maintaining clean design and robust tests.
Right.
Imagine you're using a third-party library to handle payments. Mocking this library directly would tightly couple your tests to its implementation.
So if the library changes, our test could break even if our own code is correct.
Exactly.
Okay.
By only mocking interfaces that you control,
Mm-hmm.
you create a clear boundary between your code and these external dependencies.
Yeah.
This makes your system more modular and your tests less sensitive to changes in third-party code.
So it's like creating a buffer zone between our code and the unpredictable world of external library.
Yeah, great analogy.
Okay, cool. Now, I'm also curious about how they approach testing those interactions with third-party code where we don't have that direct control.
So they advocate for using adapter layers to bridge the gap between your code
Okay.
and third-party libraries.
Okay.
So these adapters translate between the interfaces that you define
Mm-hmm.
and the specific implementation of the external system.
Like a universal translator for our code.
A perfect analogy.
Okay.
And then To ensure that this communication is working as intended, you would write specific integration tests.
Ah, so we got to make sure our universal translator isn't garbling the messages.
Exactly.
Okay.
These integration tests verify that the adapter is correctly translating between the abstractions in your code
Right.
and the concrete implementation of the third-party system.
This is starting to paint a really clear picture,
Mhm.
We use TDD to guide our design. We focus on how objects communicate,
Yeah.
and we use mock objects and adapter layers to isolate our code and make it more testable.
You're getting it. And remember, the tests themselves are just one part of the equation.
Right.
The real magic lies in the design thinking that TDD promotes.
So it's not just about writing tests, but it's about using those tests to steer us towards better design decisions and more robust and adaptable software.
Precisely. Now, another important aspect they delve into
Okay.
is how to test code that interacts with databases.
Right.
This can often be tricky because databases introduce state and persistence into the mix.
Yeah, databases can be a bit of a beast to handle in tests. You have to worry about, setting up test data,
Right.
cleaning up after yourself, and making sure that your tests don't interfere with each other.
They offer some really practical advice about tackling these challenges.
Okay.
They recommend using techniques like test-specific databases
Okay.
and transaction management to isolate your persistence tests.
So it's like having a separate sandbox for each test where we can play around with the database
That's a good way to play.
without affecting the real data.
And they highlight another important point, testing your object mappings.
Object mappings, that's where the ORM magic happens, right? Where we map our objects to tables in the database.
Exactly. They advocate for a round-tripping approach,
Okay.
where you save an object to the database, retrieve it back,
Okay.
and then compare the original object with the retrieved object.
So we're making sure that what goes into the database comes back out in the same shape.
This ensures that your mappings are correct and that your data is being persisted and retrieved as expected.
This is all incredibly insightful. I'm starting to see how TDD, coupled with, these thoughtful testing practices, can really help us build, more reliable and maintainable software.
And that's just the tip of the iceberg. There's so much more to uncover in this book.
Well, I'm ready to dive deeper. Let's explore some of those, more advanced techniques and strategies
Sounds like a plan.
they offer for writing clear, concise, and effective tests.
We'll uncover those gems in the next part of our deep dive.
Okay, so we've established that TDD is this powerful design tool, but I'm curious to learn more about how to write tests that are actually helpful and not a burden to maintain.
Yeah, that's a crucial point. Tests should be assets, not liabilities.
Right.
The authors have some great advice on writing tests that are clear, concise, and easy to understand.
Yeah.
They almost become a form of documentation.
Right, because who wants to decipher tests that look like they were written in, some ancient code?
No one.
Yeah.
So the authors advocate for a few key practices.
Okay.
First, use descriptive names for your tests.
Okay.
So instead of a generic test adding items,
Right.
you might have illustrates items in the order they were added.
Okay.
This immediately tells you what the test is verifying.
That's much more helpful than trying to guess what's happening based on, cryptic test names. It's like reading a clear headline instead of a vague subject line.
Right. Another suggestion is to minimize setup code.
Okay.
The focus should be on the behavior being tested,
Yeah.
not on tedious setup routines.
Yeah, I have definitely been guilty of overcomplicated test setup in the past.
Right.
Sometimes it feels like I'm building a whole separate application just to prepare for the test.
And the authors are big advocates for what they call the test docs convention,
Okay.
where test names read like sentences documenting the expected behavior. This makes the tests more readable and self-explanatory.
So it's about turning our tests into a narrative that clearly explains what's going on. I like that. It makes them more accessible to anyone who reads them.
And they suggest applying this clarity not just to test names, but to the variables and values within the tests as well.
Right.
So instead of using a generic X, use descriptive names like expected discount or shipping address.
So it's like we're giving meaningful labels to everything in our test environment, making it easier to follow the logic and the intent.
Exactly. And they also emphasize using structure to make your tests more readable.
Okay.
Instead of having one giant method,
Yeah.
break down the test into smaller, well-named helper methods
Okay.
that group related actions and assertions.
So it's like breaking down a complex recipe into smaller, more manageable steps.
Exactly.
Okay.
Each helper method represents a distinct part of the process, making the overall test easier to understand.
I like that a lot. And they make this crucial point about focusing on the what of the test, not the how. What do
Yeah.
you mean by that?
So what I mean is that your tests should clearly communicate the behavior being verified
Right.
without getting bogged down in implementation details.
Okay.
So instead of asserting on the specific value stored in an object's private fields, you might assert on the overall state of the object using a custom matcher.
Okay.
This way, your test remains valid even if the internal implementation of the object changes.
That's a really good point. It's about testing the outcomes, not the inner workings.
Right. You want your tests to be robust enough to withstand refactoring and code changes without constantly breaking.
Right. Speaking of robust tests, complex test data can be a real headache.
Yeah,
Do they offer any solutions for that?
absolutely.
Mhm.
They recommend using builder objects to streamline the creation of test data,
Okay.
especially when you're dealing with objects that have many parameters or intricate relationships.
I'm picturing like those helpful little kits you get with, build-it-yourself furniture.
Exactly.
Yeah.
They make the assembly process so much smoother.
Yeah, so instead of calling like a long constructor with like a laundry list of arguments, we can use a builder to kind of assemble our object in a more structured and, self-documenting way.
Precisely. And they also suggest using custom matchers for comparing objects,
Hmm.
particularly when you're dealing with tricky data types, like dates and times.
Oh, dates and times. Those always seem to cause problems in testing.
Instead of comparing the exact millisecond values,
Okay.
they recommend creating matchers that focus on the relevant aspects of a date or time,
Right.
like the day of the week or the time zone.
Yeah. So if I only care about whether something happened on, a Tuesday, I don't need to like sweat the exact hour and minute.
You got it.
Okay, cool. Are there any other like golden nuggets of wisdom that they share about writing effective tests?
They have one that might seem counterintuitive at first.
Okay.
Avoid using null in your tests.
Wait, really? But null is like the go-to value for, missing or empty data?
While it's common, they argue that using null can actually make your tests less clear and harder to maintain.
Okay.
It kind of obscures the intention behind that missing value.
Okay, I see their point. So what do they recommend using instead?
They suggest creating specific objects or values that represent the absence of data. So, for example, instead of returning null when a customer isn't found,
Right.
you might return a missing customer object or an empty customer list.
It's like giving a name to the emptiness.
Exactly.
Okay.
It makes the intention much clearer and avoids any ambiguity.
I like that. And this principle ties into their concept of self-describing values.
Yeah. Okay. Yeah.
These are values that clearly communicate their purpose within the test.
Okay, so instead of using a generic value like 666 as like an invalid customer ID,
Right.
I might create a constant called invalid customerid.
You got it.
Okay.
This makes the test more readable and understandable.
It's like turning our test data into like a dictionary where
Yeah.
each value has a clear definition.
Exactly. They also have some interesting advice about testing strings,
Okay.
which can often be a source of brittleness in tests.
Right.
They suggest focusing on the essential information conveyed by the string
Okay.
rather than demanding an exact match.
So if I'm testing like an error message,
I might check that it contains certain keywords or phrases rather than like asserting on the entire string.
precisely,
Yeah.
this makes your tests more robust and less likely to break due to minor changes in wording or formatting.
That's really helpful. It's about testing the meaning, not the exact structure.
Now, switching gears a bit, they also provide insight on the nuances of working with JMock,
Okay.
which is the mocking framework they use throughout the book.
Mm-hmm.
They emphasize the distinction between expectations and allowances when defining mock behavior.
Oh, yeah, I remember reading about that. It was a bit confusing at first. Can you refresh my memory on the difference?
Sure. So expectations describe the interactions that are essential to the protocol being tested.
Okay.
They're like the main actors in a play.
Right.
Allowances, on the other hand, support the interaction being tested,
Okay.
but they're not the primary focus, more like the supporting cast.
Okay. That's a helpful analogy.
Yeah.
So if I'm testing a method that sends an email, setting an expectation on the email service would be crucial,
Yeah.
while like stubbing out a logging call might be an allowance.
Exactly. You've got it. Allowances are often used to provide data to the object under test
Okay.
or to put it into the correct state,
Right.
while expectations verify the core interactions being tested.
That clarifies things a lot. And they also have this interesting perspective on invocation order,
Right.
which is, the order in which methods are called on a mock object.
Exactly.
Yeah.
They advise against being overly strict about invocation order
Okay.
unless it's truly crucial to the behavior being tested.
So if the order of operations doesn't affect the outcome, I shouldn't worry too much about like enforcing a specific sequence.
Exactly. It's about finding the right balance between rigor and flexibility.
Okay.
If the order doesn't matter, allow the methods to be called in any order.
Right.
This makes your tests less brittle and easier to maintain.
Makes sense. But what if the invocation order is important for the test?
For those situations where order does matter, they have a clever trick,
Okay.
using what they call a states object, to define a state machine that tracks the progress of the test.
A state machine. That sounds pretty advanced.
It might sound complex, but it's actually a very elegant way to manage invocation order.
Okay.
You can attach, then, clauses to your expectations to trigger state transitions as the test executes. It's like creating a flowchart that guides the execution of your test
Okay.
and ensures that things happen in the correct sequence.
So it's like having a director who calls out the cues for each actor in the play.
You got it. Now let's delve into their strategies for testing specific types of code,
Okay.
starting with persistence. They offer some really practical advice for testing code that interacts with databases,
Okay.
which is often one of the trickiest aspects of software testing.
Yeah, databases can be a bit of a black box. You put data in and you hope it comes out in the right form, but you never quite know what's happening behind the scenes.
They emphasize the importance of isolating tests that affect persistent state.
Okay.
This ensures that your tests run quickly and reliably without interfering with each other or corrupting shared data.
Yeah, because we don't want our tests to be bogged down by slow database operations
Right.
or to leave behind a mess of test data that could skew the results of other tests.
Exactly. They recommend techniques like using test-specific databases and transaction management
Okay.
to keep your persistence tests clean and contained.
So it's like having a separate sandbox for each test
That's a great analogy.
where we can play around with the database without worrying about breaking anything in the real world.
And they also stress the importance of testing your object mappings.
Object mapping, that's where the ORM magic happens, right? Where we translate between our objects and the database tables.
Precisely. They advocate for a round-tripping approach,
Okay.
where you save an object to the database, retrieve it back,
Right.
and then compare the original object with the retrieved object.
Okay.
This verifies that the data is being correctly mapped and persisted.
So we're essentially making sure that what goes into the database comes back out in the same shape. It's like sending a message in a bottle and making sure it arrives back on your shore with the message intact.
They also have some great advice for testing asynchronous code,
Okay.
which can be challenging because of its unpredictable nature.
Ah, yes. Asynchronous code, where actions happen in their own time, like a chorus of singers, each following their own rhythm,
Right.
not always harmonious.
They emphasize the importance of making your asynchronous tests deterministic,
Okay.
meaning that they consistently produce the same result regardless of timing variations.
Right, because we don't want our tests to like pass 1 minute and fail the next just because of some random timing issue. Deterministic tests are our friends when dealing with like the unpredictable world of asynchrony.
Exactly. They offer several techniques to achieve this,
Right.
like decoupling your code from time-based events, using probes or pollers to wait for specific conditions to be met before making assertions, and synchronizing your test thread with the asynchronous operations.
Okay.
It's all about bringing order to the chaos.
They also point out a common pitfall that developers often fall into.
Yeah.
Hidden timers.
Right.
What are those exactly, and why should we avoid them?
So hidden timers are timers that are set up indirectly or implicitly within your code.
Okay.
They could be difficult to track
Right.
and often lead to unpredictable behavior,
Okay.
making your code harder to test and debug.
So it's like having a ticking time bomb hidden somewhere in our code base.
Their advice:
Yes.
avoid them altogether.
Okay.
Instead, explicitly manage any time-based dependencies using an external scheduler
Right.
that you can control during testing.
Okay.
This makes your code more transparent and easier to test.
So it's like having a stage manager who cues all the actors in your play, ensuring that everything happens on schedule and in the right order.
Now let's shift our focus to another area where they offer some really valuable insights: managing complex test data. This is a pain point that many developers can relate to.
Oh, complex test data. It can be a real struggle.
Yeah.
Sometimes it feels like I'm spending more time setting up elaborate test scenarios than actually writing the test code itself.
They have some great recommendations for taming that complexity.
Okay.
For example, they suggest using builder objects to streamline the creation of test data.
Right.
especially when you're dealing with objects that have many parameters or intricate relationships.
Builders, those are like those helpful little kits you get with build-it-yourself furniture, right?
Exactly.
Okay.
They make the assembly process so much smoother.
Yeah, so instead of calling a monstrous constructor with a mile-long list of arguments, you can use a builder to craft your object in a more structured and self-explanatory way.
Precisely. And they also suggest using custom matchers for comparing objects,
Okay.
particularly when dealing with tricky data types like dates and times.
Dates and times, those perennial troublemakers in the world of testing.
Instead of comparing the exact millisecond values, which can lead to brittle tests.
Right.
They recommend creating matchers that focus on the relevant aspects of a date or time.
Okay.
For instance, if you only care about the day of the week, your matcher can ignore the precise hour and minute.
So instead of getting bogged down in irrelevant details, I can just check if something happened on, say, a Wednesday.
Exactly.
Yeah.
It's about testing the essence, not getting lost in the minutia.
Makes perfect sense. And I remember them advocating for another seemingly unconventional principle,
Right.
avoiding the use of null in tests.
Yes. While null is often the default for missing data, they argued that using it can obscure the intent of your tests and make them harder to maintain.
I've never thought about it that way. So what do they propose as an alternative?
They recommend creating specific objects or values that explicitly represent the absence of data.
Okay.
For example, instead of returning null when a customer isn't found, you might return a missing customer object or an empty customer list.
So it's like giving a name to the void.
Exactly. Instead of using a generic placeholder, we create a specific representation for the absence of data.
Right.
This makes the intention much clearer and helps avoid ambiguity.
And this ties into their concept of self-describing values,
Yes.
which are values that clearly communicate their purpose within the test.
Right.
So instead of using a generic value like 666 as an invalid customer ID, I might create a constant called invalid customerid.
Precisely.
Huh.
This makes the test more readable and understandable, like adding labels to all the components in a complex machine.
And speaking of components, what do they have to say about testing strings, those often verbose and detail-rich elements of our code? I know those can be tricky. Sometimes a tiny change in wording can cause a test to fail, even if the underlying logic is still correct.
They recommend focusing on the essential information conveyed by the string and avoiding overly precise assertions.
Okay.
Often using hamcrest matchers to check for specific substrings or patterns can help.
So instead of demanding an exact string match, I might check that it contains certain keywords or phrases that capture the core meaning.
Exactly. This makes your test more resilient and less likely to be affected by superficial changes.
Okay.
It's like recognizing a song even if it's played in a different key or with a different arrangement.
Right.
We're testing the essence, not the exact structure.
That makes a lot of sense. Now, I'm also curious to hear more about their recommendations for testing code that interacts with databases, which is often a tricky area.
They have a lot of great advice on this topic. First and foremost, they emphasize the importance of isolating tests that affect persistent state
Okay.
to ensure that your tests are fast, reliable, and don't interfere with each other.
Right, because we don't want our tests to be bogged down by slow database operations or to leave behind a mess of test data that could corrupt other tests.
Exactly. They recommend using techniques like test-specific databases and transaction management
Okay.
to keep your persistence tests clean and contained.
So it's like having a separate sandbox for each test where we can play around with the database without worrying about breaking anything in the real world.
That's a great analogy. They also highlight the importance of testing your object mappings,
Okay.
the layer that translates between your objects and the database tables.
Object mappings, that's where the ORM magic happens, right?
Exactly. They advocate for a round-tripping approach
Right.
where you save an object to the database, retrieve it back,
Okay.
and then compare the original object with the retrieved object.
Okay.
This ensures that your mappings are correct and that your data is being persisted and retrieved as expected.
It's like sending a message in a bottle and making sure it arrives back on your shore with the message intact.
Now, another challenging area they address is testing asynchronous code,
Okay.
which can be tricky because of its unpredictable nature.
Asynchronous code where actions happen in their own time, like a chorus of singers, each following of their own rhythm,
Yeah.
not always harmonious.
They emphasize the importance of making your asynchronous tests deterministic,
Right.
meaning that they consistently produce the same result regardless of timing variations.
Deterministic tests are friends in the fight against unpredictable failures.
They suggest several techniques to achieve this, like decoupling your code from time-based events,
Right.
and using probes or pollers to wait for specific conditions to be met before making assertions.
Right.
Synchronizing your test thread with the asynchronous operations is also key.
Okay.
It's all about bringing order to the chaos of asynchronous code. They also point out a common pitfall that developers often fall into:
Okay.
hitting timers.
Hidden timers sound like a recipe for debugging nightmares.
They can be. Their advice: avoid them altogether.
Okay.
Instead, explicitly manage any time-based dependencies using an external scheduler that you can control during testing.
Okay.
This will make your code more transparent and easier to test.
So it's like having a stage manager who cues all the actors in your play, ensuring that everything happens on schedule and in the right order.
Now let's shift our focus to another area where they offer valuable insights:
Okay.
managing complex test data.
Ugh.
Ah, yes, complex test data. Sometimes it feels like I'm spending more time creating elaborate test scenarios than actually writing the test code itself.
They have some great recommendations for taming that complexity.
Huh?
For example, they suggest using builder objects to streamline the creation of test data,
Okay.
especially when you're dealing with objects that have many parameters or intricate relationships.
Builders, those are like those helpful little kits you get with build-it-yourself furniture, right?
Exactly.
They make the assembly process so much smoother.
They do.
Yeah, so instead of calling a monstrous constructor with a mile-long list of arguments, you can use a builder to craft your object in a more structured and self-explanatory way.
Precisely. And they also suggest using custom matchers for comparing objects,
Right.
particularly when dealing with tricky data types like dates and times.
Oh, dates and times, those perennial troublemakers in the world of testing.
They recommend creating matchers that focus on the relevant aspects of a date or time, like the day of the week or the time zone, rather than comparing the exact millisecond values, which can lead to brittle tests.
So instead of getting bogged down in irrelevant details, I can just check if something happened on, say, a Wednesday.
Exactly. It's about testing the essence, not getting lost in the minutiae.
Makes perfect sense. And I remember them advocating for another seemingly unconventional principle,
Right.
avoiding the use of null in tests.
Yes. While null is often the default for missing data, they argue that using it can obscure the leet.
Okay, so we've covered a ton of ground on TDD and writing effective tests. Is there anything else that really stood out to you from the book?
Yeah. You know what I found fascinating is that the authors really emphasize that difficulty in writing a test can often be a sign that the design itself might need improvement.
Oh, that's interesting. So instead of fighting with the test, we should see it as an opportunity to step back and rethink our approach.
Exactly. If you're finding it difficult to test a particular piece of code, it could be a sign that it's too complex, too tightly coupled, or maybe violating some of those core design principles we discussed earlier.
Yeah, it's like the code is trying to tell us something.
Right.
Like, hey, help me be better.
I love that analogy. It's a reminder that testing isn't just about finding bugs. It's also a powerful tool for guiding us towards better design and more maintainable software.
So it's not about writing tests for the sake of writing tests, but about using them to drive better design decisions and create a more robust and adaptable system.
That's the heart of it. And, the authors leave us with this really powerful message. TDD is a journey of continuous improvement, both for our code and for our understanding of software design.
Well, I think we've thoroughly unpacked growing object-oriented software guided by tests today, and I feel like I have a much deeper appreciation for TDD and the power it has to, shape the way we think about building software.
It's been a pleasure diving deep into this classic with you.
Absolutely.
I always find something new to appreciate every time I revisit it.
For sure. And for our listeners, we highly recommend checking out this book if you haven't already. It's full of valuable insights and practical advice that can truly transform the way you approach software development. Until next time, happy coding.